past the hours. The official recording and process has started, so hopefully everybody's happy with that, and welcome to today. I'm absolutely delighted to be able to introduce Wilco Cope, who's going to talk to us about the replacement of feeder 9 in the River Humber in the UK. A.Hak, along with National Grid, obviously completed an incredible engineering feat and execution in the field. So I'm looking forward to hearing about that. Obviously, the Pipeline Industries Guild, we regularly do webinars, and thank you for everybody who supports us by attending and those who offer to do them. I'm sure this is going to be informative, but obviously if you've got questions or comments, please write them in the chat function as we go through. To the end of the presentation, we'll pause for those questions and answers, and I'm sure Wilco will be able to answer all of them. And if he can't answer any of them, we can always follow up afterwards if that's appropriate. So this is obviously an exciting project, and our industry around the world is challenged from time to time to come across difficulties and solve them by engineering and execution in the field. Wilco and I actually are also on the board of PLOCA, which is the International Pipeline Contractors Association, and we do get a perspective of what's going on around the world. I have to say, from a UK perspective, this is truly an amazing engineering feat, and on the world stage, it's truly an amazing engineering feat. So congratulations to all those involved in its successful completion. And I'd like now to hand over to Wilco to take us through what will be a very enjoyable presentation. So Wilco, over to you.
Thank you, Adam. I hope everyone will hear me well. Thanks for the Pipeline Industry Guild for having the opportunity to present this project, which we built in an integrated joint venture with Skanska UK and SPOR Germany. I will lead you through this presentation, which captures 4 years of preparation and execution, and I try to do it in 30 minutes, so there might be a slight chance that I need some extra minutes, but yeah, I will try to do my best and rush most probably through lots of information, where please do use the opportunity for via the chat box asking everything you want, and I'm trying to do my utmost best to answer every detailed question if these are made. So let's start. My name is Wilco Cope, director in HAK, and I'm representing HAK for all the international activities in pipelines, high voltage cables, trenchless crossings, and whatever you like, as long as it is underground infrastructure, let's say. This project is in the UK, close to Hull, and this project will include project details of the challenges in making a tunnel, and especially the pipe insertion in the coming 30 minutes. What happened, what's the case, was the business case nearly for National Grid. There was an existing pipeline which was built in 1984. It was trenched through the Humber River, and this pipeline is a very important one for National Grid, which is transporting 20% of the whole British gas consumption. There were sections of the pipeline which were on risk because of erosion of the riverbed. There is a tidal difference of 6.5 meters in the Humber, so very, very impressive, I would say. And yeah, there were some short-term solutions made to protect the pipeline, but really National Grid needed a long-term solution to replace this existing feeder pipeline into a long-term stable situation, which was in the end of lots of, let's say, evaluations, a tunnel. The project was awarded in 2016, so lots of years ago. It was decided to build a tunnel and to insert a pipeline in this tunnel. The award was to A.Hak, Skanska and Spor in the let's say the joint venture, and the award was made on the basis of an alternative bid. We as joint venture made an alternative bid, in particular how to install the pipeline, and yeah, this method we proposed was the alternative. The scope of the project was 5.5 kilometers to build 42-inch internal diameter gas pipeline for 70 bars pressure, working pressure. The tunnel itself was 5 kilometers, 4.86 in detail, and we had to install, of course, a cathodic protection as well, and connect the pipeline to the both AGIs, above ground installations at both sides of the tunnel and the river. Above the ground, it was a special area, very environmental sensible, and we had to protect all the wildlife, what was there, badgers, birds, etc., which asked a lot of attention from us, which we did with lots of success, I have to say. Underground, the geology we had to drill in was mainly chalk, and the tunnel was pretty horizontal, going down at Gox Hill to here to Paul. Lots of challenges where you see here, this is the footprint of the, if you see my dotted kind of red dot, this is the area, the area of the project, which was 1 year before we entered there. The floor was completely flooded. So there was a chance that it would be flooding again under special circumstances. So all the vulnerable elements like offices, generators, etc., we had to lift up to protect ourselves from the water. Another real challenge was that the tidal of the Humber River had a difference in height of 6.5 meters, which had the impact in the tunnel during execution of the tunneling as well, where we had to work in compressed air, where we had to go up to 3.5 bars over pressure, compressed air in the tunnel area. The tunnel itself had an internal diameter of 3.65 meters, externally 4.1 meter. It was pretty horizontal, and under the estuary of the Humber River, we drilled with an overburden of 33 meters. This is an image of the TBM, the tunnel boring machine. It was a machine of Herrenknecht, made in Germany, brand new on specifications of the joint venture. It had a length of 110 meters, 500 ton weight, and this is during the factory acceptance test. We made the segments for the tunnel in Ireland. The weight of every ring had a weight of 8 ton, and here you see, let's say, the challenge of, let's say, the internal diameter of the tunnel looks bigger, 3.65 meters, but when you see what to install in the tunnel, like this infrastructure to feed the TBM to bring fresh air to the front, and then have to bring the tunnel rings with this machine. Then you see everything is pretty narrow, if you like. This shows the multi-service vehicles, the MSVs, how we called it, 30 ton in weight, own weight 12 ton, and it had a payload of 12 ton of these segments, and there we could drive in and out in the tunnel. We did our own safety and training program. All the members who want to come on site or work on site are been trained and inducted by us. And here you see, by the way, the facilities of the office all lifted up and to protect themselves, let's say the office against the flooding. We as project management, I was in the JV board, and we had every month a kind of a dashboard where we try to capture the highlights and the lowlights maybe on the project into one pager, where our project manager had to inform us on topics like safety and quality, production and performance, the SWOT of the project, and the commercial side of life. That is combined with a monthly joint venture meeting and a safety tour, what we did together with the client on all aspects of the work. Here you see a very nice overview of a part of the project site. Here you see in my red dot the start shaft of the project. Oh, sorry, of the TBM. At the horizon there you see the River Humber, and here you see a little bit the dimensions of the project. At the right hand side at the horizon you see the pipe stock and the stringing yard. So here you see to the Humber, and to the other side that's this photo here, the start shaft again, and here you see all the pipe stocked, and let's say the area where we are going to string the pipes into to prepare the tunnel. Here you see the dimensions of the TBM again. Here it is starting to do the tunneling, and then the tail end of the TBM is just here on 110 meters away from the TBM shield itself. Some details in the start shaft. This gives an overview of the pipe string yard. At the left-hand side, pipes will be welded in strings and more or less been installed into the fire line of the tunnel. This is basically the firing line, and then it enters. This pipe string will enter in the tunnel entrance. So the TBM tunneling took 14 months to arrive in this reception shaft, and this reception shaft had a diameter of 15 meters. This shows you with this impression how the TBM enters into the shaft, and after we take out this TBM, there you see an impression how we install the pipe and connect it with a kind of a gooseneck to bring the pipe up close to the surface. After we developed an own, let's say, kind of an own safety culture program on site, after a few years of hard work, we were recognized as the safest working contractor for National Grid. That was for us very good. Having this after lots of hard working, of course, you can understand that. When we completed the tunnel, that was really a breakthrough event on itself, and there we invited a lot of stakeholders, the area with lots of people who lived there, of course, some very important people of the client, and one special guest, Graham Bonas, who crossed the river in a wetsuit already, and now we invited him to cross the river again into the tunnel itself. This has been shown in a very short video in the coming minute.
We're getting ready to push our 5-kilometre pipeline inside the tunnel. This is going to be a world record breaking event. It will be the longest hydraulically inserted gas pipeline in the world. We're really pleased today that Graham could come and join National Grid and the project team to celebrate this massive engineering feat of building a 5-kilometre tunnel underneath the River Humber. This is transformational engineering at its best, and we're really pleased that we're able to celebrate this today. It's a massive project for National Grid and for our partners.
Well, today has been a fantastic experience for me. I've actually had the opportunity to walk underneath the Humber, and I don't mean underneath at high tide, I mean actually underneath in a tunnel, and it was just like fantastic. What a great piece of engineering. You know, we look at things like the Humber Bridge and what we're doing development-wise in the city, things like the wind industry, and then we look at this and it's just a fantastic piece of engineering. I didn't even know it was here, and many of the people in Hull won't know it's here. Talking to one of the guys down there, it was fascinating to know that now it's finished, they're going to fill it back up with water. So we've walked in it dry, now it's going to be full of water. Amazing. I must now hold the record for being across the river in the most different ways. I've done it at low tide, I've done it at high tide in a special suit underneath the bottom. I've walked even over the bridge, and this one's truly unique. It's been a fantastic experience and a big tick box for me.
Yeah, I can show you even lots more of videos. We had a BBC on site, but maybe I share it with the guild for the records. But yeah, this is it. Now we go to the real work. Maybe we're going to the pipe insertion. In a nutshell. During the tunneling excavation itself, and during tunnel work, we're already preparing the stockpiling of the pipes. We welded it some semi-automatically already and transported it into the firing line. And after the tunnel completion, and after the machine was completed, we have to strip the tunnel, install the cathodic protection, and had to flood this tunnel with water again. This is an impression of how we brought all the pipes to Scotland, where it was in the factory produced with concrete weight coating. The pipe insertion activity was never done before in a scale like this, and it needed a detailed scheduled chain of activities with all the witnessing and approval steps well prepared and scheduled. This is a sketch of the stringing yard to stock 400 pipes and to weld it into 8 strings. Here you see the stringing yard realized in its real dimensions. All the 8 pipe strings had a length of over the 600 meters, as said, and the string most at the left side of this photo. Here, or let's say here, sorry. There you see it in the firing line. With a smart rail and bogie system, we were able to, let's say, winch the 600-meter pipe strings into the firing line after the first string was positioned and pushed into the tunnel. And yeah, the insertion method, it was, we filled the tunnel with water. And the selected method to install the pipeline was by pushing the pipeline into the tunnel. We as A.Hak own 2 heavy capacity thrusters for direct pipe trenches technology, and these thrusters were selected to push these pipe into the tunnel. And the combination of the pipe thrusters and the rollers should then push the pipe into the tunnel. And the concrete weight coating helped to protect the pipe coating, of course, together with collars, which was installed before insertion. The selection of pipe thrusters had some positive advantages. The pipe thruster allow for a better and continuous control of the pipe string installation. It minimizes the rotation during installation, and it minimized uncontrolled movement risks, and it reduced the installation time really. And the cross-river communication is not as critical with as it is in a winching operation. And the ability to use this equipment to push the pipe in, it can pull the pipe out when it is necessary as a contingency measurement in case of problems. Lots of tunnel commissioning checks will be done before the tunnel had to be flooded. The CP system had to be installed. TBM utilities had to be removed. We installed this CP system at 9 and 3 o'clock. And as part of the whole preparation, the insertion was simulated by BIM, and lots of workshops were held, as well as several peer reviews. And this overview shows all the 8 string in and outside the tunnel over the insertion, where with the previous overview, this led into a calculation of the weight of the string in and outside the tunnel. And with that, it all led into calculating the push and pull forces which was needed to install the pipe. And the calculations gave that the expected force of a maximum of 400 tons were needed to push the pipe into the tunnel over the length of the 5,000 meters into the tunnel. And with this calculated forces, the engineers double-checked whether the tunnel and the pipe should be intact after installation. So we needed 2 thrusters and all the rest to let the thrusters work, of course. The whole operation of insertion was controlled by not more than 10 crew members, excluding the welders who had to weld these strings together. We expected to need 22 days to install and do all the acceptance tests for the machinery. And these thrusters have a stroke of 5 meters, and every 5 meter stroke of the thruster, we expected to have a 20 minutes operation per stroke. We expected to need 5 to 8 days, including looking to wear and tear of all the machines and rollers to install every string. At the end of the day, in practice, we needed only 2 days to install and 1 day to connect the string. So that was much better than expected. The whole window of installation, setup, demobilizing and installing the pipe, we expected to need 109 days of this whole insertion operation. Here you see the impression of the setup and installing the 500 tons thruster. And here, short before the tunnel mouth in the shaft, There we installed a 750 tons thruster. And here you see at the right side the pipe rollers along the insertion line, leading the pipe into the tunnel entrance. Here you see the PU colors, specially developed. Left-hand side, here you see the pipe traveling over the rollers to the tunnel, and here you see how the pipe rolls from the stringing area up to the tunnel. Here you see the control cabin and the 750 tons thruster. And there you see the pipe entering in the tunnel, and there it starts to float into the water. Well, during the installation, we saw the stringing yard getting more and more empty, and that is where it was all about. And finally, after 4,920 meters, the pipe reached the overside of the River Humber in the reception shaft. And then finally, the work was done, and we received a certificate which said we were officially amazing. So after finishing the installation of the pipe, the tunneling and pipe insertion was successfully completed. The pipe was delivered. It was done safe according to health and safety regulations and our own restrictions, if you like, only because of the great commitment and performance of our site team. Innovative thinking and the challenging status quo of the team gave a great opportunity to meet cost and time in installing this pipe. And we delivered a world record for the longest continuous pipe string to be installed into a tunnel. The last 1 minute video is made where Paul Hammond, one of our pipeline engineers, looked back on 5 years of working on the Humber River project.
My name is Paul Hammond. I'm the pipeline engineer for A.Hak. This pipeline's name is the original one has become slightly endangered, but over the years the tide has washed away the cover and it started to pop up. So once we have this new pipeline fully installed, we will decommission the old one in the riverbed and divert the flow into this new pipeline.
It takes about a day and a half to then push that 600 metre long string into the tunnel, and then we spend half a day welding the next string on and counting that weld ready to push again. So basically, to insert the pipe, we are using specialist pipeline equipment. 2 pipe thrusters, one in the stringing field behind you, which is a 500-ton machine, and the one at the front, which is putting it into the tunnel, is a 750-ton machine. It extends, travels along the pipe, it re-grips the pipe, and then it pulls the pipe directly into the tunnel.
Keep going well, we should be finished in about 8 to 10 months. Yes, so everything you see here will be either buried or completely removed, and it will be back to farmable land again. Proud to be part of the A.Hak team, which has undertaken the world's longest pipe insertion. It's been a challenge, but it's been a great experience.
That's the end of the presentation. I hand over to Adam again.
Well, thank you very much, Wilco. That was absolutely superb. And it's, you know, so wonderful to see the technology of this pipe thrusters, but also the fact that the very initial, when you formed with your colleagues at JB, that you had an alternative bid, as in had a solution that you as a contracting entity together thought could do the job, and clearly it did the job so very, very well. We are getting some questions, so I'll start going through some of those. Obviously, the videos also helped us to understand, you know, exactly what happened, and quite a few of the comments are actually congratulating the whole team on what you managed to achieve. You know, I think a great comment from Phil Croft there, that sometimes we forget to celebrate engineering and construction achievements like this, which is, you know, absolutely incredible and should be praised so much, particularly to have done it when at the end of to completing this project, for the end of the project to be in the beginning of this global pandemic. It's wonderful to see you know, positive things about what the teamwork can do, and it was obviously from your images, Wilco, so neat and tidy and you know, looking safe, and you know, also good to see how your safety performance you know, was recognised by National Grid. So a couple of questions we have here. Well, one question asking, you know, after this project's completed, what actually happens in the tunnel with the water? Does it stay, or is it actually grouted up? Perhaps you could answer that one for us, Wilco.
Thanks for the question. Thanks for the remark of Phil, and my best regards to Phil, by the way. The tunnel will not be grouted. The tunnel stays in the shape that the water, which was treated water, purified water is not a word, that stays in the tunnel, and that has a function to protect the pipe together with the cathodic protection. So it will not be grouted, and basically National Grid asked us to design a tunnel with a lifetime of 120 years, where the pipeline is designed for 40 years. So in principle, this tunnel can be used again for a new pipeline or other facilities, but especially that's why National Grid decided to keep it in water and not grouted.
Excellent, thank you. So Sarah was asking, did you actually need a marine license to undertake the works? Obviously you're going underneath the river, but do you actually need, or a tidal estuary, did you actually need a marine license?
Not that I'm aware of, so I don't think so.
Good. A friend for us, many people know Chris Clement. I mean, Chris also commented, and I should have emphasised more, that this is a really environmentally sensitive area, and I know you commented in your early part of your presentation, but again, a wonderful achievement to be not only the engineering in a complex you know, solution, but you mentioned you're working in floodplains, you've got a lot of ecology to manage, and it looks like it's obviously was all completed in line with that. So you know, congratulations to everybody involved. There was one question you might not be able to answer. It was there an original design as opposed to your alternative bid that you may not be able to answer that, or feel you can answer that? But
so the question is,
was the original brief from National Grid, although you mentioned you put in an alternative in effect to the bid, what was there a design included in that was alternative to what you did?
Yeah, basically the original tender asked us to install the pipe in a dry tunnel and install the pipe over rollers. And there we had our concerns. What happens when one roller will fail during the installation? Then someone has to go into the tunnel, which was not ideal, looking to safety, etc. And basically how to de-install these rollers when we install the pipe. And if you keep the rollers as permanent, then the cathodic protection is more needed for these rollers than the pipe itself. So that's where we came by saying, when we leave the rollers out, what to do then? And then we came to, let's say, the very basic things of life. Let's fill it with water and float it in. So that is basically the how it went into coming into a proposal of the alternative bid.
Oh, well, thank you for explaining that, and then hence the significance of the PU spacer to be able to rub on the crown of the pipe and also obviously the direct thrust method. So superb. So thank you for that. So everybody on the call, are there any more questions? Any areas, please just type them to us so we can grab it. But whilst I start concluding, I mean, it's truly an incredible project, well executed, both from the contractor, but also obviously the client being of the mindset to be fully integrated into the project. And to get through the environmental conditions as well as the tidal floodplains and so on and so forth. And I think other comments people have made about the original 1984 pipeline, which obviously had a design life from nearly 40 years since that was put in. It's great to see that some of the future proofing the idea that the tunnel design life is a lot longer. So if necessary, the pipe could be replaced, and as you clearly articulated, without grouting it in place, the removal of the tunnel presumably can be done in the reverse of its installation. There was one more comment coming. In terms of the tunneling, did you actually have any ground conditions that you weren't expecting, or which therefore affected the execution, or did the actual TBM carry on, sail on by in her own way?
No, well, the soil investigation, of course, it is always an indication. So it is, when you do the tunneling itself, then that is the best soil investigation you can do. We weren't that unhappy with the quality of the soil investigation what was made by the client. So that gave us that we went through several layers of the ground, and especially when we nearly were completing the tunneling, there was a very weak spot in it, and that was given us the most of the concerns. And there we grouted a little bit before the TBM went through that layer of the ground to harden it up, basically, because that area was so soft. We were concerned that the TBM would go off track and not following the drilling line. But for the rest, yeah, the chalk, etc., that went pretty well. And we were several times stopped the TBM and inspected the with divers the cutting side of the cutting wheel, and that went all pretty okay. So we hadn't unovercomable difficulties with the soil, and we were happy with the soil reports which was given to us.
Excellent, and thank you for that slightly additional colour of the way you had to do a little bit of ground stabilisation before the TBM got there, but superb. Right, so ladies and gentlemen, I think we're coming up to the time. I just got two things to do. Firstly, obviously on behalf of the Pipeline Industries Guild, sorry I didn't introduce myself. I'm the former national chair of the Pipeline Industries Guild and current board member, and delighted to see so many of you here today. Probably like me, we're all a little bit fatigued from working from home because of COVID, and really encourage you to look at the future events. And one of the events I just wanted to call out was our first face-to-face dinner, which is going to be occurring on the 2nd of December in the Wales and the West area, which actually the location of the dinner is in Bath, where I'm actually speaking to you today. But equally as important is an opportunity just prior to that dinner for our prestige lecture done by Colin Skellett from Wessex Water. So that will be, I'm sure, an interesting talk. So please go to our website, and the Pipeline Industries Guild website, and have a look and pre-register for events. And I'm certainly looking forward to next March for the national dinner, and I'm sure Wilco will be over. I can thank him in person for a wonderful presentation, and the entire team. So many people who have worked so hard in our industry over their lives were involved in this project. Across the whole of all the roles needed. But Wilco and A.Hak, thank you so much for this presentation today. Truly amazing. I'm glad so many of you are sharing in this Guinness Book of Records, and maybe the Guinness Book of Records celebrating this achievement, perhaps as a country, the UK, and as an industry, we should make sure that we again celebrate what an incredible thing the team achieved. Whilst the gas flow was uninterrupted, replacing such a critical asset through such an area of sensitivity, and to have done it with the background of the end of COVID, etc., coming along, it's wonderful. So thank you for your presentation. Thank you everybody for joining, and sincerely we look forward to seeing you on future webinars, and enjoy the rest of your day and week. So once again, Wilco, thank you so much for your presentation. Goodbye, everybody.